This video is for lesson 4-2 about angles and angle bisectors. Learning goals are to apply the angle addition postulate in problems involving angles and to use the definition of angle bisector in problems that are about angles. We start off by discussing how to measure with a protractor. This is a picture of a protractor. You've used this in the past. To use the protractor, you'll notice you have the straight edge along the bottom, which you line up along one ray of an angle. Position the center or pointer part of the protractor at the vertex of the angle, and then wherever the other side of the angle is crossing through a number, you're counting up from the right and reading off the number. Occasionally your angle might be positioned so that it opens from the left side, and then if your protractor has numbers that count around from the left, you can use those numbers to find the angle. So here are a few angles. Angle AOB, so A to O to B. The ray is crossing through right here at 50. That's 50 degrees. Next one, angle BOC. So from B to O to C, that it's going from 50 to 90. So the difference between them is 40 degrees. Angle AOC. So A to O to C, that's a perfect right angle, crossing through at 90 degrees. Angle EOD, this time we're over here on the left side. E to O to D, that's crossing through at that number, 30 degrees. The measure of angle BOD, so from B to O to D, it's going from the 50 all the way to the 150, so finding the difference, that's 100 degrees. And the last one's 130 degrees. Number 2, use a protractor to determine the measure of each angle. We're not going to take the time to actually use the tools, but again, lay the bottom straight edge along one of the rays, and then wherever the other ray is crossing through the number, read the number off. Here are the 3 measurements for this picture. Question 3. Using your results from items 1 and 2, describe any patterns that you notice. So let me just scroll that back so we can see number 2. Please notice that angle TQP, this one right here, is 115 degrees. And that angle TQR, that's this one right here, is 24 degrees. And then the very large obtuse angle measured all the way across was 139. Do you see the relationship between these 2 angles that are inside of the large one? These add together to equal the large angle. So a very similar idea to the last lesson where we were studying segment addition. This is angle addition. So here in purple I've written out what I noticed. The measure of the larger angle is the sum of the measures of the smaller angles inside that large angle. So question 4, here's a chance to use that idea. Given that point D is in the interior of angle ABC, describe how to determine the measure of angle ABC without measuring. First thing that's helpful is to draw a picture of what's described. So it talked about angle ABC, and I drew some random angle called ABC. Point D is in the interior, and so I located it between those rays, and then drew a ray in green. So the idea is, can we measure angle ABC, not by measuring with a protractor, but if we knew this measurement and we knew this one? And that idea was expressed in purple, how you can add them together. And I've written that out in symbols. The measure of angle ABC, that's this large one, is equal to the measure of angle ABD, that's this one, plus the measure of angle DBC, and that's this one here. So those 2 angles inside the large one can be added together. That is called the angle addition postulate. It's a lot like the segment addition postulate. Question 5, let's use the angle addition postulate to complete some problems. Like with segments in the last section, if we draw pictures of what's described, it will help us see the relationships involved. P is in the interior of angle XYZ. So I started by drawing some random angle called XYZ, and I put P in between the rays. Angle XYP is 25 degrees. I labeled that here in green. And angle PYZ is 50. I labeled that here. Find the measure of angle XYZ. So I want the large angle, and I have those two numbers to work with. I think that's 75 degrees. Question B. M is in the interior of angle RTD. So I drew angle RTD, and I put M somewhere on the interior and drew this ray. RTM is 40, labeled in green. RTD is 65. So the large angle is 65. I drew an arc and labeled it 65 degrees in light blue. Question is, find the measure of angle MTD. We're looking for this right here. So how about taking the 65, subtracting the 40 to find that missing part? That's 25 degrees. Question C. H is in the interior of angle EFG. Here it is drawn. The measure of angle EFH is 75. Filled it in green. The measure of angle HFG is 10x. I filled that in green. And the large angle is 20x minus 5. I drew an arc and wrote 20x minus 5. So this picture can help us with the relationships. I think it's those two angles in green that add up to the one in blue. So let's do that right here. 75 plus 10x equals 20x minus 5. If we hadn't drawn the picture, we could still get this, but it'd be a little harder to just think of this in our heads. Let's subtract the 10x so that we have 10x left on the right side, and we'll add the 5 over to the left side, creating 80. So dividing by 10, we have that x is equal to 8. That's one of the things we were asked. X is 8. Okay, we want to find the measure of HFG. That's the one with the expression 10x. So if x is 8, this is 80 degrees. Question D. Lines DB and EC intersect at point F. So here we see that line and that line intersecting at point F. If the measure of angle BFC is 44, there to there, so 44 right in between, and AFB is 61, so AFB right in here, 61, then find these three angles. So the measure of AFC, we're looking for this angle. Looks like we can add those two together. That's 105 degrees. Now let's find the measure of angle AFE. We need to find where that is. A to F to E. So right in here, we're looking for this measurement. Well, do you see the straight line EC? This angle that we're looking for, added to the one we had just found out, makes 180. That was that idea about supplementary angles. And so 105 plus 75 is 180. Okay, finally, the angle EFD. So E to F to D, we're looking for this one right in here. And I see that that is a vertical angle to the 44 degree angle. Again, this is from a previous lesson. We discussed how vertical angles are equal in size. Okay, besides angle addition, another idea in this lesson is bisector of an angle. The bisector of an angle is a ray that divides the angle into two congruent adjacent angles. For example, if ray BD bisects angle ABC, then angle ABD is congruent to angle DBC. We see that illustrated in the picture. As long as this ray is splitting that angle exactly in half, then we get these equal parts, these congruent parts. So number 6, given that ray AH bisects angle MAT, determine the missing measure. I've drawn a quick sketch over here to help us to do this problem. If angle MAT is 70, let's find that. MAT, so the large purple one is 70 degrees. What about MAH? That's just going to be half of the 70, 35 degrees. Next question. If the measure of angle HAT is 80, then what's MAT? Okay, so HAT, H to A to T. This one right here, if that's 80, then what's MAT? What's that whole angle? How about 80 and 80 is 160 degrees. You can use definitions, postulates, and properties of algebra to determine measures of angles. Here's example A. If ray QP bisects angle DQL and the measure of angle DQP is this algebra expression, and the measure of angle PQL is this algebra expression, determine the measure of angle DQL. It's certainly going to help us to have a picture of this. And so here is a drawing down here at the bottom. We have angle DQL, and we're told that QP is a bisector. So this ray here is drawn so that it perfectly splits this in half. We're told that angle DQP is 5x minus 7. So down in our drawing, we could label angle DQP as 5x minus 7. And we're told that angle PQL is 11 plus 2x. So down here in the drawing, PQL is 11 plus 2x. What's the relationship between these expressions? Because this runs right through the middle, it's a bisector, these are equal to each other. And that's where this equation right here comes from. And then this can be solved using the normal algebra steps to come up with an answer for x. Next, we have some try these questions, so I'll pause the video for you to work on these. All right, moving on. Number 7. Angle A and angle B are complementary. Remember what that means. That means they add to 90 degrees. The measure of angle A is 3x plus 7, and the measure of angle B is 6x plus 11. Determine the measure of each angle. So knowing these add to 90 is what allows us to create the equation. 3x plus 7 plus, now the other angle, 6x plus 11 equals to 90. 3x plus 6x is 9x. 7 plus 11 makes 18. Subtract 18 on both sides of the equation, and that makes 72. And then divide by 9, getting x equals 8. Don't stop there. We were asked to determine the measure of each angle. All we've done so far is found an answer for x. So let's take that 8 and put it in for x and over here as well. 3 times 8 is 24. 24 plus 7 is 31 degrees. So the measure of angle A is 31 degrees. Okay, now let's get the measure of angle B. 6 times 8 is 48, and 48 plus 11 is 59. We can do a quick check and make sure that these two numbers do add up to 90. Now, question 8. In the diagram at the left, so this picture over here, line AC and line DB intersect as shown. Looks like they're intersecting here at point E. Determine the measure of angle CEB. So CEB. We're looking for this angle right here. And what I notice is that this angle and this one have algebra expressions. Do you see that straight line across there? We can use that idea about supplementary angles. If we add those two angles together, the 5x plus 68 plus the 9x, then that makes 180. 5x plus 9x is 14x. Subtract the 68 from the 180, and that is 112. Then divide by 14, and we'll have an answer for x. That makes 8. Okay, don't stop there. Determine the measure of angle CEB. Okay, all we've done so far is get an answer for x. So for example, when this says 9x, and we know that x is 8, that's like knowing that this is 9 times 8, or 72 degrees right there. Or over here, if x is 8, then 5 times 8 is 40, and 40 plus 68 is 108 degrees. That angle and the one we're looking for are vertical angles. They're created by the intersecting lines, and they're in those opposite spots to each other. Those are congruent. So the angle we're looking for, angle CEB, that is 108 degrees. Next, we have some check your understanding questions, so I'll pause the video for you to work on these. In this lesson, we discussed the angle addition postulate. It's a lot like the segment addition postulate. You're able to add angles together to equal to a larger total angle. We also discussed this idea angle bisector, kind of like a segment bisector. It cuts an angle into two congruent angles.